So here we're being asked to make a table of values and sketch the graph given the starting value, the starting equation, and we also want to find the ratio of change. And what's going to be important later on is relating this ratio of change to something in the table, something in the graph, and something in the equation. So I'm giving you some new notation. So this is my independent variable x, my dependent variable y, which is going to be written as y equals f of x, because really these are the same, and this is my output for my function. So as an input for the function, it's always good to have a 0 in there, okay, as a starting point, 0 and 3. Because of this relationship, I think I want to graph some negative values, so I'm going to maybe go -2 for x, and y is going to be negative times negative is +4, plus 3 is 7. So -2, +7. 0, 3 is my starting point. Put a few other random points in there. It doesn't matter what point you use, because what we're really looking for is the pattern. Okay, so when x is 2, y is going to be -1. And again, I'm looking for a straight line pattern. It looks like I'm on the right track. -8 plus 3 is -5. So 4, -5. They all seem to line up in a straight line. Looks like the right pattern. So there's my graph. So I'm going to sketch this graph in. Okay, so there it is. Okay, so the last part is to find the ratio of change. So I find the ratio of change like this. Do it in green. I'm going to look at the ratio of change here. It's +2 minus 4. Looks like it's +2 minus 4. +2 minus 4. We can find the ratio of change on the outside of the table, the changes. We can also see the changes this way, -4 plus 2. You can see that as the slope triangles on the graph. And if I simplify this, so -4 to 2, that's my change in y, and I'm going to be more formal with this, so I'm going to compare my change in y to my change in x. It's going to be -4 to +2, which simplifies to -2 to 1. And that ratio of change seems to be showing up as my multiplier. And we've kind of alluded to this before. And this is definitely something that we're seeing over and over and over. And we really should be making this connection. The ratio of change, which is the slope, which can be shown as ratio of change like this. And we can also start writing our ratio of change as a fraction like this of -2 to +1. And it seems like, and it's no coincidence, it seems like it's showing up as a multiplier in the equation. Not only that, it looks like the y-intercept is showing up as my plus part of my equation. Let's do the same thing here. Let's make a table of values. Okay, so definitely we want to start with a 0. We don't need to start with a 0, but we want to make sure we have 0 in there. So 0, -1 is my starting position. I'm going to maybe put a couple negatives in here. So -2, it's going to be -6 minus 1 is -7. I'm going to go up to, let's just go up by 1. And I'm going to end up at 2, and let's go up to 4, and I'm going to go up to 11. Okay, so I haven't made my changes consistent on here, but again, we're not looking for the changes, we're looking for the ratio of change. So -2, -7, 3, 5, 7 right there. 0, -1, 1 over 2 up. It looks like my points are starting to form a straight line. 4, 4, 6, 8, 10, 11, right about there. I kind of should have maybe chosen a better number, but there it is. There's my 4 over 11 up. It looks like my points are all lining up, so that's all good. We should expect all our relationships to be lining up like this because we're only focusing on linear relations this year. So there it is. And I want to know the ratio of change. So I'm going to look at my ratio of change here. Plus 2, plus 6, plus 1, plus 3, plus 3, plus 9. Okay, so how is this ratio of change showing up? The change in y compared to the change in x. We can write it as 6 to 2, 3 to 1, or 9 to 3. Okay, those are all the same ratio of change. So as a unit rate, which is useful, change in y over the change in x, I can write it as 3 to 1. Now, where did it show up in the equation last time? Well, it showed up on my multiplier. Actually, maybe I should have maybe kept the same color, but showing up as my multiplier here, that ratio of change, and then the starting value of minus 1, there's my starting value, 0, x is 0, y is minus 1, is showing up as the plus part or the minus part of this equation. And these are some connections we want to start making because we can start understanding where the math parts of these equations are now. And we want to be able to connect it to table, equations to tables to graphs. Okay? They're interconnected, so we want to understand where do the slope and the positioning parts show up in my equations, tables, and graphs. Okay? On my graph, it's going to show up like this. My slope is going to be plus 1 plus 3. Plus 3 plus 9, or 9 to 3. Okay? And it shows up as a slope triangle. So those things are connected. The ratio of change on the outside of the table, the slope triangle, and this multiplier are connected.